Hello guys, welcome to this new video. In this video we are going to solve another dynamics problem, actually a problem in fields dynamics. It's another actually question of Iran's physics Olympiad at level 3. It's not very hard question. It's just to write actually equations and solve the differential equation and just this. We should actually write the Newton's law, and then actually we can obtain some differential equations and then solve those equations to find the answers. Let's read the question. As you can see in the picture, we have a particle with mass m1 which is attached to a massless rope with length l1. It is the particle m1 which it is actually attached to the rope m1 which it is attached to the rope with the length l. The other side of rope is connected to another particle with mass m2. Here is another particle with mass m2 which can move freely along the rod. Actually the rod is frictionless and we don't have friction in this problem. At t equals 0, while the system is balanced, we tap m1 such that its velocity increases to v1. Suppose that the domain of angular oscillation is so small so that we can consider m1 just has horizontal movement. It means that this angle, let me to write something here, this angle which the rope actually has with the vertical, it's theta, and theta is so small we can say that theta is very small, so that we can actually we can consider m1 just has horizontal movement. It says that take the origin of x-axis, the initial places of two masses. Here is x equals 0. The question wants us actually to find x1 function of t and x2 function of t. Okay, what should we do is that let me to copy this picture, paste it here, write something on it, and we should actually the first step is actually to write the Newton's law and to obtain some equations. Consider that in the previous video I proved that if the rope is massless, the tension in the rope is actually a constant value. So here the rope is actually massless, so we can consider that here the tension is T, and here also it's T. And if we consider that this angle is equal to theta, this angle is also theta, and also we have gravity downward G. So if I want to write the equations for block 1, for particle 1, we have two equations, one in the x-axis and one in the y-axis. We take the y-axis like this, it's y-axis, and it is x-axis. Okay, for the x direction we should actually say that minus t sine theta is equal to m1 x1 double dot. X1 double dot means that we took two derivative of x1, which we can obtain the acceleration of m1 in the direction of x, and in the x hat, and in the y direction also we have let me to write this like, because we don't have actually any movement in the y direction, the question says that we can consider that m1 just has horizontal movement, so we don't have any acceleration in the y direction for m1, so t cosine theta is is equal to m1 times g. For the second particle, we can just write the equation in the x axis, and in the y axis we don't have any new equation, because here we have an n, which it is the force that is actually entered to M2 by the rod. So if I want to write the Newton's law in the x-axis, I can write T sine theta is equal to M2 x double dot 2, which it is the acceleration of the second particle, and also T cosine theta is equals to n plus, actually sorry about this, T cosine theta plus M2g is equal to n, which n is extra unknown. So this equation don't give us any new things. So I we don't need this equation. So I use we can suppose that theta is so small. We said that theta is so small. So in the small thetas, we know that the sine of theta, we can replace sine of theta with theta, and cosine of theta with 1 minus theta to power 2 divided by 2. And also we can actually eliminate this term, because it is too small, and we can say that cosine of theta is just 1. So with these assumptions, we can write the equations like this, that minus t theta, it is equal to m1 x double dot 1, and t theta, and t is equal to, it is equal to m1 times g, and also here t theta is equal to m2 x double dot of 2. And here I said that we don't need this equation. Okay, then we have just these three equations. There is another equation with which we should actually have, because we have here 4 unknowns. One of the let me to write unknowns here. Unknowns. It is t, theta, x1 and x2. We have 4 actual unknowns, and just we have 3 equations: equation number 1, equation number 2, and equation number 3. So we need another equation to obtain these 4 unknowns. The other equation is just the condition on the condition on the length and x1 and x2, according to the fact that the rope is constant. The length of the rope is constant, and it's equals to L, and we can write that equation I call it geometric condition, which it is you can see here that x1 minus x2 is always equal to L sine theta, which if theta is very small, we can say that x1 minus x2 is equal to L theta. So it is the 4th equation. So with these equations, we can we should solve the we should find x1 and x2 of t. But how should we do? If you see the equation number 1 and 3, we can understand that m1 x double dot 1, if we add these 2 equations to each other, we can obtain that let me to write number 1 is minus t theta minus t theta is equal to 1 x double dot 1, and equation number 3 is that if I add these 2 equations to each other, I have m1 x double dot 1 is 0. And if I integral from this, if I integrate I have integral integrate with this equation, I can obtain that m1 x dot 1 plus m2 x dot 2 is equal to something constant. And what is that constant? We can actually use this equation at time t equals 0. At time t equals 0, we have x dot 1 at time 0 equals to v1, because actually we tapped here. The question says that at t equals 0, while the system is balanced, we tap m1, just its velocity increases to v1. So here and x dot of 2 is 0, because it is actually motionless at that time. It doesn't have any movement. So here we can obtain that m1 x dot 1 of t plus m2 x dot 2 of t is equal to actually m1 x dot 1 at time 0 plus m2 x dot 2 at time 0, which it is m1 v1. So actually m1 x dot 1 of t plus m2 x dot 2 of t is equals to m1 v1. And another and again, if we integrate with this equation, we can obtain the places time with the function of t, m1 x1 of t plus m2 x2 of t is equal to m1 v1 t times t. I suppose that you know how to integrate from the constant or and something like that. It is so easy, plus another actually constant, which we can again use this equation at time 0. x1 of 0 is 0, because we consider that these two particles are at the origin at time t, and t is 0. So we can obtain that c prime is equal 0. So m1 x dot x1 of t plus m2 x2 of t is equal to m1 v1 t. This is actually one equation for x1 and x2. We need to have another relation between x1 and x2 actually to obtain each x1 and x2. But what is that actually equation? Here we use a trick. That we saw that from equation number 1, that minus x double dot 1 is equal to minus t theta divided by m1, and from number 3 we obtain that x double dot 2 is just t theta divided by m2, and from the actually second equation we found out that t is equal to m1g. From here t equals m1g. So I can substitute t in these equations. And obtain that x double dot 1 is equal to minus g theta, and x double dot 2 is just m1 divided by m2 g theta. m1 divided by m2 g theta. And also we know from the fourth equation that what was the fourth equation? The fourth equation was that this x2 minus x1 is equal to L theta. So theta is x1 minus x2 divided by L. So if I substitute theta in these actually equations, I can obtain that x double dot 1 is minus g x1 minus x2 divided by L, and x double dot 2 also is m1 g divided by m2 x1 minus x2 divided by L. Okay, so if I actually subtract these two equations from each other, I can we can obtain that x double dot 1 minus x double dot 2 is equal to actually minus g divided by L, and we can actually factor x1 minus x2. So here is 1 plus actually m1 divided by m2. Okay, and now if I actually move this side to this side, and actually we can change parameters x, we can actually think that x1 minus x2 is another parameter z with the function of t, and by this assumption z double dot is just x double dot 1 minus x double dot 2. So z double dot is going to be just g divided by L 1 plus m1 divided by m2 plus z is equal to 0, and I can say that g divided by L 1 plus m1 divided by m2 is just omega to power 2. So we obtain that z double dot plus omega to power 2 z is equal to 0, and it's just a differential equation, second order differential equation, which actually we know the answer is just we can obtain that, we can actually solve this differential equation. If you don't know anything about differential equations, or if you don't know how to solve this, how to solve different kinds of differential equations, I will actually, you can comment down, and I will actually record a video about differential equations, and I put some exercises in that video. Okay, I suppose that you know how to solve this differential equation. It is easy. It's a homogeneous differential equation. You consider that z is just e to power r times t, and just you can solve this differential equation by substituting this, and you obtain that r to power 2e to power r times t plus omega to power 2e to power r t is 0. We can eliminate this, and we can say that r is just positive minus actually I omega, and if our actual roots of the characteristic equation is something like this, it is complex, so the answer is just if you, for example, let me to write a note here. Our note is that if the roots of our characteristic equation is if our complex numbers, for example, our root is something like a plus ib and a minus ib, our answer is going to be for example, is going to be y of x is equals to e to power a times x, a constant, we call it c1, sine bx plus c2 cosine bx. cosine of b. Our answer is going to be something like that. Here our a is 0, our a, according to this note, our a is 0 and our b is just omega. So our answer is going to be something like z of t is going to be something like c1 sine, and the b is omega, omega t plus c2 cosine omega t. So actually we should find actual c1 and c2 about with the initial conditions. What was z? Z was just actually x1 of t minus x2 of t, and so here we have x1 of t minus x2 of t is equal to c1 sine omega t plus c2 cosine omega t. And also because it is second order differential equation, we should have two actual initial conditions, first for the places and the second for the actually, sorry about this, and the second for the actually second for the velocities. So I take a derivative from this expression, derivation from this expression, x dot 1 minus x dot 2 is going to be c1 omega cosine of omega t minus c2 omega sine of omega t. I suppose that you know how to actually derivate from the actually trigonometric expressions. So if I use the for initial conditions at t equals 0, we know that x1 at time 0 minus x2 at time 0 at time 0, no, not is going to be 0. So it is equal to sine of 0 is 0 and cosine of 0 is 1, so it's equal to c2. So c2 is 0, and here x dot 1 of t is v1. Yes, a v1 minus 0, x dot 2 of 0 at time 0 is 0. It is equal to c1 actually omega, so c1 is v1 over omega. So we found out that x1 of t minus x2 of t actually is equal to v1 divided by omega sine of omega t. And from this equation we understood that actually from, I call it the I equation, and according to the actually I equation, we understood that m1 x1 of t plus m2 x2 of t is equal to actually m1 v1 times t, m1 times v1 times t. Okay, here we have actually two unknowns, which they are actually x1 of t and x2 of t, and also we have two equations. So we can actually from these equations solve x1 and x2, which if we solve this actually our x's are going to be, x1 is going to be something like let me to write the answer here. The answer is just answer, final answer. X1 is going to be something like this. M2 divided by M1 omega. I wrote these answers before. Sorry. Omega sine of omega t, actually plus t, and x2 of t is going to be m1 v1 divided by m1 plus m2. t minus 1 over omega sine of omega t, which omega is actually just omega 2 power 2 is omega square is actually where's omega? Here's omega g divided by L, g divided by L times 1 plus m1 over m2. So this is actually the final answer, and we found x1 of t and x2 of t by actually writing the Newton's law, and suppose that, and with this assumption that theta is very small. In this actually assumption helps us actually to obtain some differential equations which we could actually solve them. We understood that here we have actually three equations which we obtained them from Newton's law, Newton's second law, and we needed, and we understood that we need another equation because we have four unknowns, t, theta, x1 and x2, and we found the geometric condition, which was x1 of t minus x2 of t equals L sine theta. Here, as you can see here, this is x1 minus x2, x1 minus x2, and x1 minus x2 divided by L is the definition of theta, sine of theta. And actually we used the assumption, and we did actually we did that trick. We used this trick that we needed to find actually two parameters. One of them was actually, for example, we can say that y1 is let me to write it capital. Y1 was actually x1, let me write x capital X1 was x1 of t plus x2 of t, and the second one was x1 of t minus x2 of t. Actually, the trick of this question was that we should find actually two expressions. One of them was actually x1, capital X1, which it was x1 of t plus x2 of t, and we found that by actually adding the actual first equation to the third equation, so that we obtained that here, and then integrate from the acceleration to obtain the velocity, and after that integrate from the velocities to obtain the places, and we found out that here m1 x1 of t plus m2 x. So let me to write here and alpha 1 x1 of t plus alpha 2 x2 of t. Here again alpha prime, for example, alpha prime 1 x1 of t minus alpha prime 2 x2 of t. If we find these actual two expressions, then we have actually two unknowns, and then two equations, and we can find the answers. First, I said that we added the equation number 1 to equation number 3 to obtain the actually first equation. I mean x1 is alpha 1 x1 plus alpha 2 x2, which it is this equation. And the second one that we use is that to actually subtract these two equations from each other, from each other to obtain actually x double dot 1 minus x double dot 2, and also we had t. We can substitute these t with these, and also we had theta from the equation number 4, which was x2 minus x1, which it is in the form of alpha prime 1 x1 minus alpha prime 2 x2, and then we actually obtained this equation. From this substitution, and after that we changed the parameters and we took x1 minus x2 as a new parameter. We called it z, which it is function of t, because both x1 and x2 are functions of t. And then we obtained a differential equation here for the z, and we solved these differential equations with this note. and we found also we found the constants of the differential equation by actually initial conditions, and we understood that x1 minus x2 is just this, and m1, and also we used this equation. Let me to copy this from here. Let me to write here equations 2 equation. One now, copy this and actually paste it here. Okay, and then we found two expressions in this form that we were actually trying to find, and then we solved x1 and x2, which I didn't write that here, and I just wrote the final answers, and this is x1 and this is x2, which omega is, we set that omega here, we said that omega 2 is just omega 2 square is just g divided by l times 1 plus m1 divided by m2, and we solved the problem. Actually it wasn't a very hard question. It just actually had some tricks to actually solve the problem. You should know that how to actually obtain from how to achieve actually differential equations from actually Newton's law, how you can actually, and then how should you solve the differential equations. If I hope you enjoyed actually the video. If you actually liked the video, we appreciate that if you subscribe our channel, and if you want us to record actually new videos in different fields of physics or mathematics, we actually appreciate if you comment below, and just that. Thank you for watching this video.